Okay, this is 5.4 homework. Today in the homework we're going to be using the formula sheet quite a bit because we have double angle identities, which are here, which give a relationship for sine of twice an angle, and it then reduces it basically because then you have, sine of just half that angle. We then have power reducing identities, which if we have sine squared, we can rewrite that. Cosine squared, tangent squared, same thing. We have half angle identities, which give us sine of an angle divided by 2, and then we just get that angle, so it could help us get rid of decimals, as you'll see in the homework. And there's sine, cosine, and tangent for that as well. So we have, in all, there's like 13 different identities that we're going to be using in this section, which is quite a bit. But the first one is a perfect example where you have this relationship right here. It gives us cosine of 30 squared minus sine of 30 squared. So we're going to look at our formula sheet and determine that here's that relationship right here. Cosine squared of an angle minus sine squared of an angle is really cosine of twice that angle. So I can make that by using this right here. I can make it cosine of twice 30. Cosine of 2u, because u in this case is 30. That's cosine of 60, and we know what that is on the unit circle. That's 1/2. Okay, the next problem gives us the cosecant of x is equal to 2 in our angles in the second quadrant. And then it wants to find these half angles. Well, half of x. So first step is to always, when they give you information about where an angle is, and they give you a trig ratio, always draw that triangle. So I'm going to draw the triangle in the second quadrant and label the cosecant, which is reciprocal of sine, is 2. That means that hypotenuse over opposite has to be 2, which if you do the Pythagorean theorem makes this negative square root of 3. Now I can write down the formula for my half angle for the first one, which is sine of an angle divided by 2. Here's the relationship. And I'm going to fill this out. I know my sine's positive here because it's the y value, so I can get rid of this negative here. I know I'm going to be positive. So my sine of x over 2, x is what we're using here, not u in this case, is equal to this. So I just have to fill this out. 1 minus cosine of x, well, my angle is x right here, which is found in this reference triangle. So the cosine of x is adjacent over hypotenuse. That's negative square root of 3 over 2, all over 2. Now, if I just simplify this and enter this answer as exact answer, that will work fine. Double negatives go positive. And it's all divided by 2, so I'm going to get a common denominator here and add these two together. So I end up with 2 plus the square root of 3 over 2. Divided by 2 is the same as multiplied by 1/2, so this just becomes a 4 in the bottom. And I have the square root of the whole thing. I know it's a little tricky to enter in, but that's our answer right there. And we're just going to repeat that same process now with the cosine formula on the formula sheet. We know the cosine is going to be negative. Actually, I think it's going to be positive because we're looking at half of the angle, and half of the angle that we're looking for is actually going to be half of the angle that they gave us. So that's going to actually give us a cosine that's positive. That's a little tricky, but so we're going to use the positive and get rid of the negative, and then just fill this out. So we have the square root of 1 plus the cosine of u was adjacent over hypotenuse, so negative square root of 3 over 2, all over 2. So simplify this, and I get a common denominator here. That gives us 2 minus the square root of 3 over 4. If you simplify that once again, that should work. Okay, then the last one is tangent. Once again, we know sine and cosine are both positive, like we said, so tangent's going to be positive. So we can use any one of these formulas. I'll just use the middle one. Looks easy enough. 1 minus cosine of u, which is adjacent over hypotenuse, which is negative square root of 3 over 2, all divided by sine of u, which is opposite of our hypotenuse, which is 1/2. Double negatives go positive here. I'm going to get a common denominator and try to simplify this a little bit. This turns into 2 plus the square root of 3 over 2, divided by 1/2, the same as multiplying by the reciprocal 2. So this cancels. My answer should be 2 plus the square root of 3. Okay, the next problem wants us to find the sine of 15 degrees, and it wants it in this form. So sine of 15, I'm going to rewrite that as sine of 30 over 2, because I can use then this formula, the sine of u over 2, the half angle identity here. To use this formula, you just plug in. U is now 30, so just plug in 30 here. So it's the square root of 1 minus cosine of 30 all over 2. Now, I know this has to be positive because we're talking about sine of 15, which we know that's a positive value. If you look at your unit circle, 15 is going to be a positive y value. So just simplify this, and you get the square root of 1 minus cosine of 30 is square root of 3 over 2, all over 2. Get a common denominator again. This turns into 2 minus the square root of 3 all over 2 divided by 2, which is same as multiplying by 1/2. So that gives us 1/4. And now they want us to pull out the value of that square root of 4 and pull that out as 1/2. Because you can take the square root of the top and bottom individually. So take the square root of the bottom, pull that out, and you end up with this, which is what they're looking for. A is 2, and B is 3.